Okay, so we're going to look at the trigonometry with the inverse trig functions, okay? So we're going to do inverse trig functions. Now, we did the notes on these in class, but I'm going to kind of go through these again. So let's look at the first part. All right. This is what we've learned with our trigonometric ratios. We know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now remember, this little symbol right here is theta. And we've talked about theta. Theta is just an algebraic representation, it's like a variable, to represent angles. Theta is a Greek symbol, and so it just indicates to us that we're getting that's the measure of an angle. It's the measure of an angle in degrees. When we use theta, we're indicating degree measure. When we get into radians, that is going to be a little bit different, okay? So we're looking at a degree measure. All right, so that's kind of a review. We're looking at these angles. Here's your angle right here. This is the adjacent leg. That's the opposite leg. That's the hypotenuse, okay? All right, so let's move up. Right here it says, calculators have keys for all three of these functions. They also have keys for their blank functions, which allow you to calculate the angle if you know it's sine, cosine, or tangent, and the answer to that is inverse. We are now looking at what we call inverse functions, okay? Functions that are inverse functions are functions that undo other functions. So for example, the inverse function or the inverse operation of multiplication is division. The inverse operation of addition is subtraction. The inverse operation of x squared, or squaring something, is square root. Now, what inverses do to each other is the inverse brings you back to x, your original value that you started with. So, for example, if I were doing like we've done with Pythagorean theorem, so for example, if I do x squared equals 64, for example, and I want to find x, I don't want x squared, what I'm going to do is I'm going to do the inverse operation, the inverse function. The inverse is to take the square root of both sides. In fact, I'll go ahead and show you that in a different color so you can see it. But the inverse is to take the square root, because what happens, this becomes 8, what happens when I square root x squared? It just becomes x. The square root and the squared undo each other. It's like tying a shoe and untying a shoe. So they're inverse operations. They undo each other and leave you with x. So that is what an inverse operation is, okay? So we're going to be doing that with these functions. So with the functions we were looking at earlier, given an angle, you needed to find the ratio of the sides. Now we're going to undo that and go backwards. Given the ratio, what's the angle? So let's look at a few of these. So the first one I want to look at, so if the tangent of A, the tangent of angle A, we're looking at angle A here. If the tangent of angle A is m over k, the inverse tangent of m over k would be A. So what I'm doing is I'm going to inverse. I'm going to take tangent A equals m over k. Ignore it. I'm going to do the inverse tangent of both sides. So I'm going to take tangent -1 of tangent A and tangent inverse tangent of m over k. What does that do? What does a function and its inverse do? Well, the tangents cancel out and I'm just left with A on this side. And then on the other side I have the inverse tangent of m over k, hence this equation. What I've done is I've undone the equation by using the inverse on each side. Inverse undoes the other function. So let's look at this one. All right, sine of A. In fact, let me use the same color here. Sine of A is m over p, opposite over hypotenuse. So if I want to find the actual angle measure A, I don't know what A is measuring. If I want to find it, I'm going to inverse it I'm going to inverse both sides of the equation, and the inverses do what? They cancel each other out. So you're left with A equals inverse sine of m over p, which is this. Again, I'm inversing both sides, so you can see it. I'm inversing both sides. So now, let's look at cosine. Cosine of A is adjacent, which is k, over p. If I want to actually find the A, what I'm going to do is I'm going to inverse it, inverse both sides. The inverse will undo the cosine function, just leave me with A. Just like up here, square root and square just left me with x. And on this side I have inverse cosine of k over p, which is that equation. So that's how you do the inverses. Now, as far as finding the inverses, what you're going to do is you're going to enter it into the calculator. Okay? So, let me scoot this here. All right? Let me actually fill this in for you. This is equal to A. That's based on these equations. I was just showing you how to get those. Okay, so that's A. That would go there. All right, so let's move on. Let's look at this particular example right here. This particular example is asking you to actually find the angle now. We're going to use the inverse functions to find the angle. So let's look at the first one. The first one says the tangent of A equals 1.5. All right. I want to find A. I want to know what the angle is. 1.5 is my ratio. Remember, all trig functions are based on ratios and angle relationships? Well, since this is tangent, we're talking about opposite over adjacent, right? So this 1.5 is the ratio I get when I take the side opposite this angle and divide it by the side adjacent to that angle. The decimals are just another way to represent the fractions. I could write this 1.5 could be 3 over 2, right? Okay? It could be 6 over 4. It could be 9 over 6. Each of these represents 1.5. So they're just writing it as a decimal to make it easier for you. Okay, so what do? I am going to inverse both sides like I've been doing. So I'm going to take the inverse tangent of both sides. And so what happens when you inverse a function? It disappears, so that leaves me with A equals the inverse tangent of 1.5. A equals the inverse tangent of 1.5. Now I don't have a calculator with me, but what you would do here is you would hit second tangent on your graphing calculator. And let me come through here. I'm using my scientific calculator here on the computer. So what you're going to do is you're going to hit second tangent and you'll do the inverse of the tangent. Now I'm going to come through, we'll come back and calculate these. I'm going to get a calculator, we'll calculate these in a minute, but I want you to look at these. How would we do part B? Well, part B would entail the same thing. It would entail the same thing. So what we're going to end up doing here is we're going to take the inverse tangent. We're knowing that, again, what does this represent? That is your ratio. So I'm going to take the inverse tangent of both sides. I'm going to inverse it so I can get rid of the function on one side. So I would rewrite this as, remember those go away, A is equal to the inverse tangent of 0.25. Okay, so the first two we've done are tangent. Now let's look at the next one, which is sine. You are going to do the same exact thing, but you're going to be using sine now. So if I'm looking at sine, it's saying the ratio here, what's sine? Sine is opposite over hypotenuse. So what this is saying is that the opposite over hypotenuse ratio for this angle is 0.88. Okay, is 0.88. So I'm going to inverse sine both sides. I'm going to take the inverse function, put your parentheses, that goes away. That leaves you with a equals the inverse sine of 0.88. Now hopefully you're getting the hang of this, okay? Any fraction or any relationship that gives you 0.88 will create an angle of A, whatever A is, in your right triangle. So that's all we're doing for each of these, okay? So let's go back and now let's re-examine the actual measures. We know that the angle measure A is equal to, he's going to give us a ratio of 1.5, opposite to adjacent. So what I do in the calculator is I hit second tangent. And there's a second tangent. I'm going to hit second, and I'm going to do arc tangent, or I'm going to do second tangent. And then I'm going to enter 1.5. And I get 56.31. Now this is asking you to round to the nearest tenth. So 56.3 degrees. If I were to enter in the calculator second tangent, or arc, this is also called arc tangent, second tangent, and enter the ratio I was given, it gives me the angle. Remember, original trig, you're given the angle, find the ratio. This trig, you're given the ratio, find the angle. So you're going the other way, you're undoing the operation. So let's do this one. Inverse tangent of 0.25. So I'm going to do the inverse tangent of 0.25. And that gives you 14.03, which is 14.0 degrees. And notice we're finding angles here. On the previous lesson we were finding sides, now we're finding angles. So let's do this one, let's do sine. So let's do the inverse sine of 0.88. And again, I'm using my calculator. So I'm going to do arc sine of 0.88, and I get 61.6 degrees. So that's how you use the inverse calculator, the inverse function, to do this. And I'll do another one with the calculator so I can actually show you the buttons on the calculator. But this is how you solve it. You do the inverse functions, you inverse both sides, because remember, an inverse function undoes another function. When you inverse each other, they cancel each other out in a way and end up with x. You'll end up with x. Just like x squared equals 64, you take the square root of both sides, x equals 8. So that's what we're doing now, is doing the inverse trig. I'm going to do the next lesson here. I'm going to do a few examples for you with regular triangles.